Good afternoon, CCS, grade 5. This is Mr. Boolsen, and we have yet another decimals lesson for today. So, as we talked about yesterday, we were just introducing decimals. So, a decimal is a system. Oh, that's so massive. Decimal is a system where you have a dot, you have 0, 3, that's a decimal, and that kind of represents, as we talked about, 3 out of 10, or even 30 out of 100, but we would draw that one more like this. But yeah, so we talked about this yesterday, and today we're just going to continue a little bit more into it. So I hope you enjoy. Anyways, continuing on here, let me grab the bigger marker. We talked about yesterday that that we can look at this in this way, and we can kind of compare tenths and 100ths, but oh no, don't want to do that. Why is it disappearing me? So, as we said, this this can represent, right? This is a box of 100, and each row is 10, so we have the whole row finished out. So we could say this is 10 of 10 100ths, or 0.10. in decimals. Now, the reality here is that this is an equivalent. There's an equivalent fraction here, which I talked about yesterday, but apparently I got ahead of myself. But it seemed kind of an obvious time to go about talking about that. So yeah, we can see here that if you do something like this, this will be 20. Now 20 over 100. But this is also equivalent. We could talk about how each of these rows, right? If you have one of these rows filled out, that's basically a tenth, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. 10 rows of 10. And so you could talk about this as having rows filled out. And you could instead say that this is equal to 2 tenths. And yesterday I showed you how you can do it like this, right? When we say that something is equal to 20, or no, sorry, 100 over 100, just like we did with fractions, remember? We can times this by 10 and this by 10 to make an equivalent fraction, which would be 20 over 100, right? So these are equivalent. And yeah, so you can see that oftentimes that when you're dealing with fractions in 100ths and in tenths, they can actually be equivalent. Now, there's one important thing to remember here when we're dealing with this, that when we talk about a fraction, say like this, 0.07, it's important to say this is 0.07. That's because that's what it is. It's not 0.7, right? But it's 0.07. Now this is even more complicated or tricky, right? When I see something like this, right, 70, or like it looks like a 70, right? I cannot say that this is 0.70. What this is 0.70. It's not 0.70. And if we had 0.71, this wouldn't be 0.71. It would be 0.71. When we're talking about decimal numbers, we do not call them by 70 or 80. We talk about each individual part, right? Because these are kind of like parts. So you'd say 0.07. So it's a bit different than normal numbers in a sense. Now, just continuing off of there, we're going to just talk about, how we can organize decimals along a number line. So we looked at number lines yesterday, and I kind of showed you this. But if I ask you something like this, 0.8 or 0.12, which one is bigger? Well, there's definitely one that's bigger, but you have to look at this and try and think. So before we even do this, we could actually go back to our grid And let's erase all that, and let's do it again. So 0.8 or 0.12. So here we could say that if we wanted to draw these out, this one, right, would be, you'd fill in this whole section here for 10, right? Because that's the 10 amount. This is the 10th, and this is the 100th amount. And then we would just circle in this, right? So this is 10 and 2, right? We could think of this as being split up into 1/10, showing 1/10 on the board, and you can show that by coloring in a whole column, and then plus 2/100ths. At least when we're drawing it here, it could be for drawing's sake. Now the difference here, right, is that this 12 is over 100. This 8, you could be tempted, right, when you see an 8. So this is actually 0.12. Sorry, I've been saying 12 because it's so easy to do that, right? It's 12 out of 100, but you have to remember that it's 0.12, and this is 0.8. And it's easy, perhaps, especially if we do say 12, right? That's why you don't say it, because it can throw you off. Because 12 is bigger than 8, but this isn't 12. This is 0.12. And this one here, which represents 12 over 100. Now, on the flip side, we have 0.8. And 0.8 means something different, right? That is talking about tenths. So this only shows the 10th column. So what this one's saying is 8 out of 10. And if we were to draw this, I'm not going to color all of these in, but we would basically say this section here would be colored, this section 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 would be colored. You would basically end up with this much of the box. Now, when you look at it like this, right, this is obviously a lot bigger than this small section, and that's right. That is how it's supposed to be, because this is dealing in tenths and this is dealing in hundreds. If we were to make this an equivalent fraction, right, 8 over 10 is equal to over 100. You times this by 10 and this by 10, and you would get 80 over 80 over 100. And when we see 80 over 100, we can definitely say that that's bigger than 12 over 100, right? And so in the end, we could say 0.8 is bigger than 0.12. So yeah, that's really important to recognize. So yeah, when we're dealing with fractions, when there are two numbers, when there's one number after the period, after the decimal point, so that dot that always follows, when there's one number after it, that means we're dealing in tenths. So in tenths out of 10. When there are two dots, or two digits, two numbers behind it, see like here, we're dealing in hundredths. So that's one way to remember that when there's one digit equals tenths, and two digits equals 100ths. So that's a good thing to remember. So if you see two digits like this, you are going to be dealing with a 100. So if I go over, let's say for here, for example, just to a blank canvas, and I give you 0.7, or let's say 0.19, what are we going to look at when I'm asking which one's bigger? Well, first off, we can say, well, this one, because I see that there's only one number, one digit after the dot, that this one's going to be out of tenths. So you could say, okay, well, this really equals 7 tenths. And this one here equals is 2, right? There's 2 behind it. And so instead of tenths, it'll be 19 out of 100. Now, when we see that, we can actually we can remember something from fractions again, that it's a lot easier to compare numbers when they're the same. And so what we always want to do is if we're dealing with a situation like this where we want to compare them, we can just go, okay, well, what's the equivalent fraction for 100? Well, you just times it by 10, right? Just the same thing on the top and the bottom. And then we get 70 of 100. And now that is a lot easier to compare to 19 over 100, and it's obviously much bigger. But when we see it like this, it can be deceptive, right? That this one could be bigger. But we have to remember is this part here, the first section, this first section here, the first digit, is dealing in tenths. So that's dealing in basically groups of 10. So if you have 0.89 versus 0.7, then this number is going to tell you the tenths, right? So over 100, this one will also tell you the tenths. So you're dealing with 7 over 10, and it's versus or 89 over 100. And an easy way to figure this out is just to times this by 10, which gives you 70, and 70 over, let's just, 70 over 100, which is a lot easier to compare, right? So yeah, that's the major thing that we look out for. Finally, yeah, so yeah, it's always good to just make them both 100s. That's a good way to use our fraction knowledge and continue to apply it to decimals, because decimals and fractions have a lot in common, obviously, as they are both kind of dealing with similar things. Now, if I was wanting to order, let's just go over here. Instead of doing this here, we could say, okay, order on this line. How about we order 0.08 and 0.60 and 0.34, and you notice how now I'm getting better at saying it properly, but yeah, you can see that I'm saying 0.60 and 0.34, not 0.60, not 0.34, it's 0.34, and that's because if we don't say it like that, it can become deceptive, and people can misunderstand us, especially as you saw that, because 12 is bigger than 8, so if you say 0.8 or 0.12, then you're not really giving the honest, you're not really telling the truth, because 0.8 is bigger than 0.12, but if you say it as 0.12, people are going to think this is a bigger number, but it's not. Anyways, if we're trying to find this on the graph, where do we look? Well, this is 10, right? And so we know that 0.8 is going to be less than 10, right? And so this one's divided up neatly into 100, so it'd be there. That's 0.8. And where would this one be? 34. Well, there's 30. So, or sorry, no, 0.34. I caught myself again. So 1, 2, 3, 4. So it's 0.34 is right here. And so from a number line, just as we've done before, 0.34, we can find again the the places where it is. And so we could say that 0.08 is smaller than 0.34, which is smaller than 0.60. And so that's basically the summary of what we're dealing with today. And so we'll just do one last thing, and then we will move on, and you guys can go on and work in your workbooks. So if I ask you a question, or if you encounter a question that's, John ran 0.3 kilometers on Monday, oops, and 0.24 on Tuesday, and I asked you which one he, oh, should do it like that, Tuesday, which day he ran more. Well, how are you gonna look at this? Okay, so let's just take 0.3, and then we're comparing it to 0.24. Now, what is the first thing we look at? Well, what's the number in the tenths area? Okay, well, here we can see that this means that this one would be, yeah, well, I guess the first thing, more importantly, is actually how many numbers are here in the boxes, like how many are after the decimal point. And remember what we said, that if there's one after a decimal point, then you are dealing with over 10, right? So this is 3 over 10, and this one is, there's 2, so you're dealing with hundredths. So this is 24 over 100. And so now we're just comparing these. And really the way to do this at this point in our work is just to find the equivalent fraction. So we just say 3, 10, and that's you times this by 10 each, right, to find our equivalent fraction, and that's equal to 30 over 100. And when I say that this is the tens one, that's because it means that it's in the 10th column, and this one in a sense is also in the tens column, right, because this makes you have a 20, this, or out of 100 it'll be a 20 out of 100, and this is a 30 out of 100, right? So it's in the tens kind of column, and this is in the 100ths column here, because this is just 1. If you just have 0.01, you're going to have 1 out of 100. And if this is an 11, or a 1 here, rather 0.11, then you have 11 out of 100. So that's why I call it the tenths column, because it kind of represents, when it's in this bar, when we're talking about hundredths, it'll be representing something out of 10. So it'll be a tens. 10, 20, 30, 40, that's kind of what I mean. Anyway, so yeah, the main idea, the crux of the matter is you want to get both into 100ths fractions, and then you just see which one's bigger. And obviously 30 out of 100, right? Remember from our fractions unit, the numerator being bigger, that means there's more pieces, and so 30 out of 100 is bigger than 24 out of 100. I know there's a lot to take in again, and there's a lot of different concepts and different ways of thinking about this. So anyways, I hope the videos helped in this case, and I hope that you have a fantastic rest of your day. Bye-bye for now.